Hello, I'm Jacob Roden. This is my Engineering 196 project going over advanced workbenches in CATIA 3D experience. This is the sheet metal workbench. As you can see here, we have our sheet metal part. This is the base of my final project. It is a machinist tool holder, carrier stand type deal. In my personal experience and some other people that I've worked with, when you have usually more than two tools, it really just depends on the type of tools that you're having to carry. You have to take them across the shop if you're replacing them or doing a setup and getting new tools. And if you have a lot of parts that you have to set up and take with you, it can get kind of annoying and waste time to have to walk all the way across the shop and get to, and then walk all the way back and get to, and so on and so forth. So I thought it would be very nice to just have a simple little carrier for it. This is just the sheet metal base. It has little plastic inserts that go into it so that the tools won't spin, and so that they have a little bit more kind of hold and clutch power in there. So this is obviously in the sheet metal design workbench. As you can see here, this is one flat piece of sheet metal that's been punched and has holes in it and everything, and we can actually see what it looks like unbent by pressing the fold unfold button right here, and we can see this is what it would look like before we put it in a press and break and everything. And these holes have probably been punched out instead of milled or machined or anything. Though if you wanted to mill and machine it, I guess you could. Just be a little bit less efficient. It just kind of depends on what you got. Now obviously we can see over here. Some of this stuff, get out the way. We can see here we have all of our different features of our sheet metal stuff, and these are all different sheet metal features. So if we fold this back up, we can kind of start and go through the process. So above all of our features, we have our parameters. Now our parameters is what you initially set, and this is just based off of maybe the thickness of your sheet metal that you're using. You have your bend radius and your K factors and your different bending allowances and things, just the different settings of how your sheet metal gets bent and kind of what those numbers are going to look like. And then you also have your material, and if you want to have a design table to put in, you can put that in as well. But we can see here we did just a sketch of a square for our base, and we used the wall tool, which just creates a wall, and it just automatically creates a wall from the sketch, and it uses those sheet metal parameters to create the thickness and everything, so you can make this whatever shape you want, and we just immediately make it, in our case, 1/8 of an inch thick. We also have, this is our safety plane. For later I'll hide that. And then we can see next what we did is we did a wall on edge with bend, which means that we can select one of these edges and it'll create a wall with a bend. And then if we click on it, we can see the setting. And that lets us pick a height, an angle, what direction it's going, the kind of positioning and everything. And in our case, we set it to 60 degrees, so it kind of creates a nice triangle shape, and just 10 inches because that should give us enough space on the wall for some tools and everything. And obviously I can select with band and different types of clearances and geometry settings that you might be having for your part. And then with this wall, we then added the kind of top handle section, which you would use to carry the whole thing. And then we added another wall over here, so that we have kind of a nice triangle shape with a handle in the middle for carrying all that stuff. Something else that we did with this is you can see our height. Instead of just choosing an actual length, we can choose up to a surface, and we were able to select this surface on the inside of this wall so that it just meets right here in the middle and touches. And if you wanted to, you could also probably just weld this if you're actually making one of these, and that would let it be very sturdy instead of this stressing and getting pulled down or something. Following that, most of this would probably get deburred during production, but these corners up here are a bit of a hazard, so I made sure that I actually rounded them with the corner tool, and that just lets you select any corners where two walls meet around them to a certain point. And you can select multiple corners at once, so you don't have to worry about setting them all at once. So if I wanted to change the radius, I'd be able to just change it all at once instead of having to go through and select multiple ones or put a function in. And I only rounded those just because if this is getting welded, you're probably not going to be able to get your fingers on those corners and hurt yourself. And then most of this stuff would probably get, like I said earlier, deburred in production or anything. After that, we put in a cutout for the handle here, and this was just sketched on a position sketch right here. And we just put in a slotted, elongated hole, and made sure that it was wide enough and had enough room. And then realistically, you might wrap something over this just for a little bit more of a comfortable carrying experience. Maybe a little thing of plastic, maybe some rope or tape or whatever. And then after that, we were able to put in our holes for our tool holder inserts. So these are just set to a certain size just to make sure that the little insert, it's got a little plastic backing, so it's like a push fit, so once you push it in, it shouldn't come back out or anything. And this just gives enough room. We should have a good angle so the tools aren't going to fall out or anything. And then we did a rectangular pattern to push it up there, and then it was not allowing me to mirror it just because I think of the way that the features are set up. So we did the same thing on this side, and then we used some functions to make sure that everything was nice and equal as it should be. And obviously here you can see kind of the final base part. We applied our material and everything, and then looking at it from this side, this should be able to hold everything without any tool holders kind of colliding and hitting each other. The pull studs, especially up here, shouldn't be knocking into each other or anything. And if you wanted to, you could move these around, maybe make this wider or taller, change these angles so that you can actually hold more tools. Or maybe if you're holding two really large tools, you might be able to make this angle shallower, make the holes bigger, depending on if you're using Cat 40 or a different kind of tool and taper style. But yeah, it allows for a lot of variance, but it's a very, very simple design. You can put it up on your table and then just grab each tool out. And especially if you're running something where maybe you're running a harder material like Inconel or something where you're going to have to replace tools a lot, it could be nice to just have a couple just set up and ready on this, and then just grab one out and then put the other one in, and then when you have to go replace a couple, instead of having to take multiple trips, you can just take the one. But that is the sheet metal design workbench for this. Obviously it's a pretty simple design, but we have a lot of different options of the different bends and material, different types of bends, and obviously we can go into all the different types of corners and cutouts and holes and pocket options that you have, and using stamps and ribs, and then all the different kinds of patterns and everything that you have the option to use. But yeah, thank you for watching, and have a great day.